Hello, grade 4 teachers. Let's have a look at some ways that you can connect computer science into your energy unit. Your computer science curriculum talks about students creating artifacts and collaborating to design an algorithm. We see algorithm, sequence of instructions, and artifacts popping up over in your curriculum a few times. There's a lot of knowledge in the computer sciences, but the lovely thing is that there's ways that you can cover this in your other areas of study, your science classes, or even your math, language arts, or social, because we're talking still a lot about designing sets of instructions, and nothing specifically says that these things are related specifically to computer coding. We know that the computer sciences organizing idea has three big ideas within. Computational thinking, design thinking, and creativity are expected to be a piece of computer science all the way from kindergarten up through grade 6. These are the common threads that tie the whole curriculum together. And in grade 4, you're looking specifically at the design process and incorporating it into your lessons. One of the computer science skills and procedures is for students to plan and create an artifact to meet a need. You have opportunities to have students doing this continually throughout the year, because anytime they make a model or some type of a prototype or an experiment or an object, they're meeting this outcome because they're planning and creating an artifact. And all of those things qualify as artifacts. It's not until in older grades that they're required to specifically create a computational artifact, which still can be many things outside of something that's actually computer coded, such as like a slideshow presentation. So when you've got students making something to show what they know, they're going to be just by design working on this computer science skill and procedure, and they're also going to be working through the design process, which is a key piece of the whole grade 4 computer science curriculum. When students are creating these artifacts as projects, they also have the opportunity to cover the skills and procedures around providing feedback during the design process and doing testing of an artifact to confirm that it meets a need. So if we've asked students to design something for a particular science concept, it may easily be that they have to do some testing and refining of their artifact, in which case we're hitting on these computer science skills and procedures and really covering this understanding about how the design process can help us design things that can meet our needs. Let's jump into your actual energy curriculum and look at some ways you can connect into some of these skills and procedures. So if we're looking at non-contact forces, we're first going to need to give students the knowledge of the difference between contact and non-contact force. And so we could do some object sorting, like in this case, or have students go and do some exploration on their own to determine what this is. When we're doing a sort like this, we're working through computational thinking. We are looking at particular attributes and properties of something. We're looking at them, so we're breaking it out into those attributes and properties. We're decomposing that. We are asking students to do some pattern recognition. In this case, we're talking about, is there contact involved in this motion or is there not? So that's recognizing patterns, you know, that these things, there's contact involved, these there's not. And then also we can move into algorithm design by asking students to come up with just some simple algorithms. If they work together, they're meeting their computer science skill of collaborating to write an algorithm. That does not mean it has to be blocks of code or something that's typed into a computer. It can be just a simple statement, as I have here. Working on if-then statements is a great way to develop the skill of algorithm design. It's also giving them the skill of conditional statements, which will come into play when they are asked to do actual block coding programs within their computer sciences. So that's how algorithmic thinking, computational thinking can connect into this. If we're asking students to create or design some type of a project, then we're going to move into that design thinking and then that creation of artifact skill too. Students are asked in grade 4 to demonstrate the effect of gravity on an object, and marble mazes come to mind. You are likely will have students who are very familiar with this. So doing a marble run design challenge is a way that you can hit this energy skill and also draw in all of this computer science. So we have some of our skills and procedures explicitly here that could be covered by asking students to create a marble run. We could give them, a specific set of instructions. We could also, show that video that was on the last slide and say, hey, how do you think you could make one? And have students determine everything from, what their materials are going to be to what their steps to building are going to be. You can ask them to lay that out in a plan. Now they're going to be working through the design process. They're also going to be, decomposing what it is that they're planning to make down into its parts. They're really going to think about all of those individual pieces and what their role is in this design. So this is an opportunity for you to check off a whole bunch of computer science knowledge, skills, understanding, and also cover this specific skill within your energy unit. Asking students to conduct an investigation, in this case to demonstrate magnetic forces, but asking them to conduct any kind of investigation is definitely going to be asking them to use their computational thinking skills. We need to go breaking things down and looking at specific attributes, finding patterns so that we can group things together. Always have that opportunity to, push beyond and building an algorithm. Here is an example of a game that connects into this magnetic force. I'm going to have students are going to, make a track where we can drive paper cars by using a magnet under the paper. This is going to demonstrate principles of magnetism. We could take this to a next level by this being on a grid similar to the unplugged spaceman activity we can see here, and ask students to, do the magnets through the paper in combination with a set of direction cards. So, I'm going to lay out the algorithm and you're going to run the magnet and the spaceman, and we're going to see if we have the right algorithm. And maybe we can do some debugging and finding errors in an algorithm here also by me giving them incorrect algorithms for this activity and having them troubleshoot. And again, the magnet with the spaceman and doing those movements. So we are conducting an investigation into magnetism, and we're also, working together to create some algorithms to solve, at this problem of the spaceman getting to his rocket ship or the car getting to its destination. Breaking things down. If you're asking students, to design and create this project, they're also doing the design thinking process for sure as they work their way through. Looking at, again, we are seeing describe, demonstrate, conduct an investigation. These are those, keywords for the same skills and procedures from the last slide, but another way to look at it. Here's another project that I found online. Science Sparks has lots of cool science activities. So here's an activity where students will create an art project where it's going to do some gravity defying. So we're actually going to be touching on magnetism and gravity within this project while we're also creating an artifact to meet a need. The need is to show that I understand how non-contact forces can affect objects. And we can look at examining the availability and cost of materials as I'm planning, like what things are available to me in the classroom. What do you think, maybe can you bring things from home? Is there a cost? Do you need to buy things? Who's paying for these things? And we're covering this, that is a skill and procedure from the computer science as well, while we're actually planning a project that connects to magnetism and electricity, and maybe even art. Asking students to analyze interactions, and here also to magnetize a material, which is going to be a pretty basic straightforward procedure. So we'll start with analyzing interactions. We can ask students to do some algorithm design when we're doing this. We can do if-then statements, and these, again, this isn't a complicated concept, so we can extend understanding magnetic poles by putting in these algorithms. If the poles are the same, then they push. If they're opposite, then they pull. We can make some connections to conversations about force. Talk about, this is like a non-contact force, and make that connection back to what we've done before. And again, we've done some of this computational thinking because we're really just looking at these specific attributes here. And we could ask for the magnetizing a material, which, as I say, is a pretty simple thing. Just tell students you need to figure out how to magnetize something, and you can work with a partner and come up with a set of instructions that someone else could follow, and then you're going to give those instructions to someone and they're going to follow them, and we're going to see if their thing gets magnetized. And so we've taken this really simple skill and procedure here in energy and drawn in some computer science pieces and just made it a little bit more complicated project. We're hitting some complicated computer science understandings, and also students are going to be able to show you that they know how to magnetize a material at a deep transfer level, because they are able to even write those instructions out specifically for someone else to follow. So those are some ways that you can connect computer sciences into your energy unit. I hope you enjoyed.